Welcome to fall of 2022. My name is Jerry Lacey, an instructor for MPT 150 Introduction to SolidWorks. I've taught for 25 years and have mostly done SolidWorks, but CAM programs, manufacturing. Like to do the mechanical design and machining builds. So let's take a quick look at the format. Make sure I'm clicked in here, and we'll close that up. Right. And so with the format, I'm going to change to a shorter, faster introductory segment where I really just want to encourage you to watch, not try to follow along or try. We'll do a separate video for the follow and click. Or if you've familiar with the information that was presented in the watch portion, then go ahead and just try it. Don't watch the say the slower or the instructional video until you've gotten well into it. Try to make it a fun process that you're challenging yourself and you're able to get into those geometries and those different shapes and see what they can do. And then I also want to provide snippets, 30 seconds to a minute on a particular topic without going into a lot of detail on the associated information, just focusing on very simple segments of a particular topic. So my recommendation is there is no such thing as perfect, only good enough. We're going to work towards perfect, but really we can design until there's nothing left, but at some point we've got to build. So whether it's traditional, subtractive, metal manufacturing, plastic, taking materials, running through the process, at some point we've got to make it. And oh yeah, and then the of course additive is the additive manufacturing, 3D printing is evolving and becoming more prevalent. We can do those prototypes very quickly. So this is an iterative evolving process. There is an avalanche of information coming your way. If you've watched the previous 900 or so videos on YouTube, watched any of those, you know that I jump around a lot. I am thinking in terms of what is the immediate need of this project? What are the things that I'm not thinking of? That's as important of as everything that you're trying to focus on. So don't get too wrapped up into the making it perfect. Let it become part of the your learning cycle. And then let's jump over to, well, let's take a quick look at the book. If you're interested in the, I don't think that reduced, but we'll go ahead with it. The Engineering, Design, and Graphics with SolidWorks 2016 is the one I'll be working with. This is the Kindle version. I make sure that this has the same projects as 2019. You can buy these used through the resellers anywhere from, it's looking like in the $20 range up. So also the 2019 book is a little more expensive, has a few more tidbits of information on the CSWA, but basically they're the same. So on the importance, why this is important to me. As a machinist, my degree is in machine tool and die, so I am a tool maker. I design fixtures in a lot of different capabilities. I work at ASU in the Instrument Design and Fabrication Core Facility, so it's Arizona State University. And the process that we use is to take the information and build in, based on material sizes, what we have available, things that are kind of common standard practice, and turn that into a usable fixture. So this fixture resulted from having a part that had 4 or 5 angular faces, and I set up tooling plates and did different angle setups. It took quite a while. And so we have rotary capability. So this is a 4th axis. If you're not familiar with machining, a 2.5 axis program, the tool will come to a location, move down in Z, perform some operation in X and Y, and then retract. In 3 axis, if you look at your mouse, the 3 axis would be to go up and over and follow the contours of that mouse, or making a mold for that mouse. And then 4th axis, this is going to rotate as well as move in those other 3 axes. So picking up an angle or a complex on a complex shape, this will rotate to position. And then 5 axis will also rotate as it's rotating about X, it will rotate about Z in this configuration. So this is part of a probing system. If you know anything about tool touch off, this will tell the tool length, and then a probe comes down and we locate for the part. So when we're working in these projects, it really comes down to, we're at the crossroads of a lot of disciplines. So it's not just drafting anymore. It's not just mechanical design. It's not just engineering. We're dealing with electronics. We're doing designing the machines that make the machines that will build the machines. So and then eventually we end up with the product. The scope of work is kind of our basis to define what we're going after. So it's your creativity and is the basis of all this information. So we're starting with a scope of work. We're going through the SolidWorks portion of it that determines how we're going to, what's going to be approved to manufacture. And once we get to that stage, then we're going to build it, and it goes into service. And that's where the terms product lifecycle and the overall usefulness of our parts come into play. So have fun with this. Keep working towards that perfect, but realize that we're going to get to this stage and say it's time to build. So have a great semester, and we will get after it.